Hey guys, welcome back. Mr. Marone here. Welcome into the second lesson in our third section here at lesson 1.3, and we're going to focus on the distance formula here. You're going to be taking these notes in your guided notes section of your handouts, and just so we're aware, we're going to be reviewing the Pythagorean theorem, which is something that I think has been kind of beaten into all of us from our middle school years. So just as a reminder, the Pythagorean theorem is a squared plus b squared equals c squared. And as you see here, you must have a right triangle to use the Pythagorean theorem. You can't use it if it does not have a right triangle. And we have a couple pieces that we identify. The first one is the hypotenuse. And it's the longest side, and it's across from the right angle. The other two shorter sides of the triangle are known as our legs. Okay, so A and B would be considered the legs, and C would be the hypotenuse. I'll draw a little triangle here so you can see. So with that in mind, we're going to find the hypotenuse for these first two examples. I'll do the first one, and then I'll let you guys try the second one. This got cut off, but this should be an 8 there as well. So looking at this, our right angle's here. So there's our hypotenuse, which we don't have. So we're going to end up having A, B, and C. So we would have 8 squared plus 7 squared equals x squared. 8 squared is 64, and 7 squared is 49. When we combine those together, we get 113 equals x squared. And we're going to take our square root there. Now, at this point, we're going to try to simplify this radical. If we can simplify it, great. If we can't, that's okay as well. I believe that one is as simplified as possible, so we would say that x is equal to radical 113. We're going to leave everything in simplest radical form when we can in this class. We're not going to find decimal approximations. We're just going to leave it as is. So at this point, go ahead and try the second one, identifying where the hypotenuse is and then setting up your Pythagorean theorem from there. All right, welcome back in. So as you see from the algebra, I ended up with x equals radical 29, and there is nothing we can do to simplify that radical, so we just leave it as is. Now, the cool part about this is that you've dealt with Pythagorean theorem over and over and over again, and the distance formula is exactly the same thing. So here's our distance formula. It says the distance, and this is all in a coordinate plane, is the difference in our x coordinates squared plus the difference in our y coordinates squared. Now, if we look closely at the picture that they gave us here, we're trying to find the distance here. That, to me, looks an awful lot like a hypotenuse. And these look like my two legs. These look like A and look like B. So we really have A squared plus B squared, and just we're doing it on a coordinate plane. Okay, so it's really just finding those distances. Remember, distance is always going to be positive, regardless of the direction. So let's take a look at an example. They gave us A, B here, and they want us to find the distance using the distance formula and then check using the Pythagorean theorem. So if we look closely, it looks like point A is negative 1, 1, and it looks like point B is at 3, 3. So using the distance formula, we would do the square root, and my two x values are negative 1 and 3, so it would be negative 1 minus 3 squared plus, and then my y values are 1 and 3, so 1 minus 3 squared. Negative 1 minus 3 is a negative 4 squared, and 1 minus 3 is a negative 2 squared. So I would have negative 4 squared is 16, and negative 2 squared is 4. So I would have radical 20, and that can be broken into radical 4 and radical 5, and radical 4 is 2. So I got a distance of 2 radical 5. Now, if we change colors quick, and we do the Pythagorean theorem, that requires that I make a right triangle here. So I'm going to make my right triangle, and it appears that this has a distance of 4, and this has a distance of 2. So if I'm using Pythagorean theorem, I would have 4 squared plus 2 squared equals x squared. Then I'd have 16 plus 4 equals x squared. And I'd have 20 equals x squared. And we end up with radical 20 equals x, which we saw over here from simplifying is 2 radical 5. So even though we've been given distance formula, you can treat it as the Pythagorean theorem if you use finding horizontal and vertical distances. Go ahead and try this problem on your own. See if you can find the distance from point E to point F using the distance formula, and then check your answer using the Pythagorean theorem. And when you come back in, both will be done on the screen for you. All right, welcome back in. So as you can tell, same thing as we saw on the front. Using our distance formula, we have -2 minus 5, which gives me a -7, and I had a distance of 7 here for my horizontal. 3 minus -3 gave me a +6, and you can see my vertical distance was 6. And so you can see that distance formula really is the same as Pythagorean theorem. If we were to get rid of this square root and put it on the other side, we would, as a square term, you'd really be at the exact same step. So you can feel free to use either one as you're working through these problems. If you have any questions, feel free to bring them into class tomorrow. I would also encourage you to re-watch this video as well. Have a great day, guys. Talk to you soon.